Hey guys, so yesterday we were talking about scale factors to solve problems with similar polygons. Now today we're going to interpret scale models and then use scale factors to solve problems. Okay, so some new vocabulary is a scale model or a scale drawing. Hopefully you've heard this in real life applications before. So it's an object or a drawing with lengths proportional to the object it represents. For example, if you have like a little Hot Wheels car, right, it's going to be pretty proportional to what an actual vehicle would be like. Or if you have a toy school bus or a fire truck or something, it's not going to be taller than it is long, you know, it's going to be proportional to the real object. Okay, and then there's also the scale, which is the ratio of the model size to the actual size. So kind of like that K value that we were talking about yesterday. Okay. So, one thing, like I said yesterday again, we use these scales on maps. Usually down in the corner there's a key that tells you, 1 centimeter is so many feet or miles or whatever, okay? So, here's a situation. We have the distance between Boston and Chicago on a map is 9 inches. If the scale of the map is 1 inch to 95 miles, what is the actual distance from Boston to Chicago? Okay, so the way that I want to solve this is I want to use it, or solve it using proportions. So that's going to be one method that we can set this up as. So when we do that, we're going to let 1 on the map over the actual, which is 95 miles in real life. So we have map over actual. Set that equal to 9 inches on the map because that's how far they were on the map, and put that over X miles, which is how far they actually are. Now once we have this proportion set up, we just apply that cross product property, okay? Go ahead and solve it, so then we get X is 855 miles. So that's telling us that Boston and Chicago are 855 miles apart. Now there's another way that we can solve this. We can use an equation. Essentially we're doing the same thing, it's just a different way of looking at this. So this is kind of long, but I'll go over it quickly. I prefer method 1, but here's a different method if you guys want to try it. So we're going to let A equal the actual distance in miles between Boston and Chicago, and then M is the map distance in inches. So we're going to write the scale as 95 miles over 1 inch, meaning that's 95 miles per inch on the map. Okay, so for every inch on the map, the actual distance is 95 miles. That's just kind of summarizing what we already knew. Okay, so here on this page, we're going to write the equation. So we're saying the actual distance equals 95 times the miles on the map. And the miles on the map was 9. So we go ahead and solve it, and we get 855. So that's just a different way of solving it. You guys feel free to use whatever you want. I'm probably going to use the proportions. I think the textbook likes the equations a little better. Okay. Alright, so pause your video right now, work this one out on a little side piece of paper if you'd like. Okay, so now we're talking about the distance between Cheyenne, Wyoming and Tulsa, Oklahoma on a map is 8 inches. If the scale of the map is 1 inch to 90 miles, what is the actual distance from Cheyenne to Tulsa? So I'm going to go ahead right away and say that 1 inch come on guys. Okay, kind of weird, but anyways, 1 inch over 90 miles equals, okay, we're given 8 inches on the map, so we say 8 inches over X miles. Okay, here's where we apply that cross product, so we get 1 times X equals 90 times 8. Okay, go ahead and solve this out. We're going to get X equals 720. And 720 what? Are we talking about inches? Are we talking about miles? This right here, we wanted X amount of miles, so I'm going to say 270 miles. So you guys at home should be getting D. Okay, so now we have to find the scale. So we're given a miniature replica of a fighter jet is 4 inches long. The actual length of the jet is 12.8 yards. What is the scale of the model? Okay, notice that the replica is in inches, and then the actual length is in yards, and that's okay. Okay, so to find this, we have to write the ratio of the replica to the actual length. So we go ahead and set that up. So we have the 4 inches over the 12.8 yards. Okay, and when we simplify that down, we get 1 over 3.2 yards. And that's the scale. So for every 1 inch of the replica, we have 3.2 yards on the actual jet. Okay, so same thing, but now it's asking, the question is a little different. It says, how many times as long as the actual is the model jet? Okay, so this, in our last question, it was asking us about the scale, and we had some inches to some yards. Well, now we want to know just a number. We're not asking for an amount of units, we're asking for a number. How much longer is the actual than the small one? Okay, so we're going to have to do a little bit of converting here. So we're going to take that scale, okay, take the scale that we had here, the 1 inch over 3.2 yards, and then we need to end up converting it to just a number. So we multiply it by 1 foot over 12 inches because that's getting us closer. And at that point, maybe I'll just do this. So we had 1 inch over 3.2 yards, multiply 1 foot over 12 inches, okay? And then we need to multiply 1 yard over 3 feet. Okay, so the numbers when we multiply across, our numerator here, we have 1, 1, and 1, so that's just 1. Okay, and then we have 3.2 times 12 times 3, we get 115.2. Now I'll explain why it's just a number and why we don't have any sort of units. Is because when we multiply inches over yards by feet over inches, our inches cross out. Okay, so those units kind of cancel each other out. Then when we multiply this by yards over feet, we have a feet on top and a feet on bottom, so those cancel out. But look, now we still have a yard and a yard, but those also cancel out. So that's why here we have the scale of 1 to 115.2. So what we say there is that the actual jet is 115.2 times longer than the model. Okay, so here's one for you guys to try. So we have a fire engine is 9 inches long, a replica of it, and the actual length of the fire engine is 13.5 yards. What is the scale of the replica? Okay, so now it's only asking us for the scale. It's not asking us how much times bigger, right? So we can still have some inches to some yards. Okay, so the way that we'll set this up is like this. So we would say 9 inches over 13.5 yards. Okay, simplify that down to get 1 on top. So then for 1 inch of the replica, we would have 1.5 yards. Okay, but we don't have that as any of our options, and we don't really want to have 1.5 yards. So if we multiply each side by 2, or the top and the bottom by 2, so 2 over 2, just multiplying it by 1, we're going to get 2 inches to 3 yards. So then the answer that you guys should be getting at home is A, 2 inches to 3 yards. Okay, now this is the same type of deal, except it's asking us that question where we have to do a little bit of converting. Okay, so we have, what did we have? We have the 9 inches over 13 yards, and we're going to multiply by 1 foot over 12 inches. Okay, and at this step, this is where our inches and inches would cancel out. Okay, but we still have to keep going because we have to get rid of these yards and feet. I'm going to put a T there. Okay, so then we would put 1 yard over 3 feet equals, and that's going to equal something. Okay, so at this point, this is where our feet cancel out here and here, and then we're still left with yards and yards, so those will cancel out. Okay, now when we go ahead and multiply these out, we get 9 over some big number, which ends up simplifying to 1 over 54. Okay, so that's saying we should be getting answer B. 54 is it's 54 times as long as the model. Okay? Alright, here's the last example. I'm going to do this a little bit differently than the book does just because I think you guys will kind of get it better. So Gerard is making a scale model of his classroom on an 11 by 17 inch piece of paper. If the classroom is actually 20 feet by 32 feet, choose an appropriate scale for the drawing and determine the drawing's dimensions. Okay, so the first thing that we need to do is figure out the scale between the classroom and the sheet of paper. So if we go ahead and do this, we could say the actual classroom is 20 feet wide. So if we divide that by the 11 inches, which is on the piece of paper, the scale it gives us is 1.8 feet per inch. Okay, now we need to check that with the length of the classroom. So we have the actual classroom is 32 feet long, so we'll take that 32 divided by 17. This 17 is coming from the sheet of paper, and it gives us 1.8 feet per inch. Okay, now the next page is going to kind of make a turn on us here. So you would be thinking that for every 1 inch on the paper is going to be 1.8 feet in the classroom, but what they're actually going to do is they're going to make that 1.8, into 2 because it's a nicer number. So then they're just going to kind of round it and round up from 1.8 up to 2. So they're going ahead and they're setting up an equation here. So they're saying that the actual length equals 2, that was our scale, times P. Okay, and the actual length was 20, so we can plug that in and solve for P. So P is 10. Okay, and now we have to do the same thing, but with the length. That was the width on the last page, now here's the length. Okay, so we have the actual equals 2 times P, and then we plug in the actual, which was 32 in the classroom. We go ahead and get P equals 16. So then for our answer, our scale is 1 inch to 2 feet, and then the dimensions are 10 inches wide and 16 inches long. So that's kind of the process. Okay, so here's our last example that I want you guys to try. You might want to use a proportion. I'll set it up, this one in a proportion, just to kind of show you the easier way of doing it. Okay, so Elaine is an architect making a scale model of a house in a 15 by 26 inch display. If the house is 84 feet by 144 feet, what would be the dimensions of the model using a scale of 1 inch to 6 feet? Okay, so this is where they give us the scale, so I'm just going to underline it. Okay, and let me just tell you how they're getting that scale. They're taking, so if we take this 84, the width, divided by 15, it gives us about 6.5. Okay, now if we look at the length, we're going to take the 144 divided by 26, and there it's an irrational number. We get 5.538, blah, 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 blah. Keeps on going and going forever. Okay, so these aren't the same, so we definitely want to round up, and they seem to think that rounding up to 6 feet made the most sense. So that's what we're going to go with. So then if we solve this kind of differently than we did the last example, okay, all we have to do is if we have 15 over x and we just divide this by 6, 6 coming from here, we get 14. Okay? And then if we take the 144 divided by 6, again, the 6 is coming from the scale over here, we get 24. So, the dimensions that we should be getting are A, the 14 inches by 24 inches. Okay. So we have another really short assignment for you guys. It's page 520. We're going to do 5 through 19